Um, Today, we're looking at mathematical induction. We're going to be trying to prove the summation formula. Recall that the summation formula is I equals 0. We start at I equals 0. We end at n, and we're simply adding all the values of I. And this is actually equivalent to n times n plus 1 over 2. But we want to prove this. So what we're going to do is we're going to use mathematical induction, and the first step to that is proving a base case. A base case. So say n equals 1. Well, when n equals 1, the left side is 1 because it's the first sequence. And the right side would be, so this is my left side, and then my right side would be 1 times 1 times, 1 plus 1 over 2, which is just equivalent to 2 over 2, and that's equal to 1. So let me remove all that. We see that our base case is true because 1 does equal 1. So our equivalent, that is a true statement. So now, base case checks out, cool. What about our inductive hypothesis? Let's make an inductive hypothesis so that we can prove for all values. So our inductive hypothesis will say let k equal n. And we're going to say that 1 plus 2 plus 3 dot 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 plus k, should be a plus here, equals k times k plus 1 over 2. So here's our inductive hypothesis. We're assuming that for some value k, where k is equal to n, that this is true. And so now we want our inductive step. So inductive step is this. We're going to say that we want to prove k plus 1, prove for k plus 1. So we're going to take our original hypothesis, I suppose, and we'll do 1 plus 2 plus 3 plus dot 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 plus k plus 1. And we're going to say this is going to be equal to k plus 1 times k plus 1 plus 1, whoops, cool, plus 1 over 2, which is also just equal to k plus 1 times k plus 2 over 2. Okay. And so now that we have this, we're going to want to prove that the two sides are actually equal. Okay, cool. So something you'll notice is this right here is equivalent to this. Because these two are equal, then by our inductive hypothesis, this is going to be equal to this. So if that is the case, then we can say that we have k times k plus 1 over 2 plus, plus k plus 1, and that's going to be equal to k plus 1 times, you know what, I'm not even going to do that yet. I'm going to put these all under a common fraction, so they'll both all be under 2. And so what I'll do is I'll do k times k plus 1 plus 2 times k plus 1 over 2. And now I'll just kind of block that off there and say this is equal to our right side, which is k plus 1 and k plus 2 over 2. And so we can multiply both sides of our function by 2, so times 2 times 2, and then this is going to cancel everything out, such that we're only left with k times k plus 1 plus 2 times k plus 1 falling asleep here. Jesus Christ. Uh, is equal to k plus 1 times, there's no 1 there, k plus 1 times k plus 2. So this is going to be k squared plus k plus 2k plus 2, and that's going to be equal to, we're going to have k squared plus 2k plus k plus 2. Wow, I'm going on an angle. Now I have k squared plus 3k plus 2 is going to be equal to, I'll add like terms here as well, k squared plus 3k plus 2, and we see that these are equal, okay? And what that means is for all values of n, our original formula holds true. So therefore, we proved this is true by mathematical induction.